Okay, welcome, Jacqueline and Ross and Constance and Brenda and Bailey and Esther and friend, it looks like. um, Thanks for coming. What we're going to be doing today is we're going to be talking about confidence intervals. So we've actually spent a few weeks now where we've just kind of done math to get ready for what we're doing now. So today is really the first day in a while that we're doing true applications. Before we had to assume we had a normal distribution, we kind of found probabilities, but now we're actually going to be doing things that in 5 seconds I can find a news article that uses it. I know where I'm looking though, but it happens all the time, and that's confidence intervals. And the idea of confidence intervals is that, as we've seen all along in the class, you collect a sample and you get your sample mean or sample proportion, and you know that's not equal to the population proportion, or it probably isn't because you just did a sample. So the big question is, how far off are you from the population mean or the population proportion? So how good a sample, how good an estimate do you have when you're trying to decide what the population parameter is? That's what today is all about, is to find out how good it is. But the other thing I want to mention, a couple things actually. One is that we're in week 6. So what happens in 2 weeks? Anyone know? So what's the big thing that goes on in 2 weeks? Very important piece. Yeah, midterm. So the midterm must be taken within 2 weeks from Wednesday. And a week from Wednesday, you need to let me know where you're taking the midterm and when you're taking the midterm. And what I have done is I have created a midterm information quiz. And that is absolutely mandatory to be able to do the midterm information quiz. So if you don't, then I just deduct 5% on your midterm, and which is really ugly. Okay. Midterm information states midterm February 27th. That was an error, so let me fix that as we speak. That's a good thing, is I can quickly fix thing. If you look at the syllabus, it does not say the 27th of February, that's for sure. That's because that must have been copied from last quarter. So let me grab that. So that's in the week 7. So I apologize if it had the wrong date. So let me do that one more time. So just a second. Midterm information. And in a second, it will not say that anymore, I promise. So when we take midterm, just a minute. Questions, here we are. Yep. I forgot to change that. It automatically does that. You must take it on and before, and then I think I'm just going to skip that. I'm going to write Wednesday, week 8. That way I don't copy and paste it again. Okay, no longer says that. That's the good news. It's not points, it's percent, which is much worse, by the way. So yeah, so you shouldn't even have to ask what happens if you don't do it. Okay, so you shouldn't even have to ask. You should just do it. That's much easier. Has to be done. My recommendation is don't wait till last minute, because it might take you a while to find a proctor. So just a reminder, because this is the time you should start looking for a proctor. Okay, and by the way, the 29th is correct, Brenda. This is the time you should start looking for a proctor. I want to remind you, we talked about this orientation, but it's been a while. If you are in Tahoe, very easy. We have a library here, and they do proctoring for free. And that is open Sunday through Friday. They're closed on Saturdays. They're not open 24 hours a day, but they're open pretty much. So you contact them and set up an appointment. I would do that right away, because there's a lot of LTCC students taking it, and they might book up when you want to take it. If you're not from Lake Tahoe, the most common place for someone to take their exam, to take their midterm, is in their local college. A lot of you go to a college already and you just go and you get a proctor there. They usually have a testing center at every college. If that doesn't work for you, maybe you're only taking this class and you don't have a college, then the public libraries often offer proctoring. And that's another place you can do it. If that doesn't work, Sylvan Learning Centers and other centers to help to tutor often have proctoring services, but they charge a bunch. And I know we have at least one person in the military, and I allow your commanding officer to proctor your test. But you have to give me the contact information. So any questions about that? Okay, so if there's no questions, let me tell you about the next big thing. The next big thing, you have more time, but you probably want to spend more time thinking about it, and that is Project 2. So Project 2 is coming up. You got a while for it, June 16th, but you know how it is, it goes fast, so about a month. One main thing is make sure you have partners. Don't assume that the partners you worked with are still happy to work with you or still in class. Or if you don't want to work with them, then you're welcome to switch partners. Okay, so you can keep partners, you can switch partners. Project 2 discussion forum is really the place to look for partners. And I have that one is posted up and it's ready to go. So that's the biggie. And we're going to talk a little bit about what you're doing towards the end of this. But first we have to understand what a confidence interval is. Are we allowed to bring a note card of equations and notes for the midterm? So Ross, the first part, yes. The second part, no. So you can bring a note card of whatever you have, but you can't bring a note card and more notes. You get one note card. And you can write front and back. Anything you want on it is fine. But you can't bring a note card and then more notes. Yeah, that's what you meant. That's fine. Yeah, 3 by 5, and let me let you know, inches, not feet. So 3 inches by 5 inch note card. You can write anything you want on front and back. Okay, good question. That's important. It's also on the syllabus. So syllabus is like the key rules of the course. Okay, any other questions before we start talking about confidence intervals? No questions? Okay, what I want to do, and I'm going to do this, and I want to make sure I write stuff down, so I'm going to do this on Paint so that you can all see it. If I go right to the chat and just refer to chat, I've realized that that doesn't work on the video, so sorry about that for last time I did that. So let me share my desktop to look at Paint. In a moment. Where is it? There it is. Okay. But you're still going to put it in chat box, but now I'm going to read them to you. So what we want to do is we want to make an estimate. Okay. And let me ask you if there's anything that you're curious about students, and it needs to be quantitative. So pop in the chat box if you have a curiosity that is quantitative. First person to put their curiosity up will make that happen. Otherwise, I'll make something up if no one does, but I'd rather you guys be curious. So take a look. Still waiting, give you a moment. Okay, GPA. All right, my rules, by the way, is you have to answer the question, but if you don't feel comfortable about telling the truth, put a number in, but don't put 7.0. That can't be a GPA. Okay, so it needs to be a reasonable GPA. So what I want you to do next, so let me type in a few things before I actually have you ask you the survey question. So the question we want, just a moment, that'll work, is what is the population mean GPA of online statistics students. Okay. I could have put all students because I'm actually taking a class right now. So I'm officially a student, not statistics though. I don't need to take that one again. So what does the population mean of online statistics students? So the first thing is, can we come up with that? Can we get the population mean GPA of online statistics students? And we'll call it in America if you want, just to keep it national. Or actually, maybe in the world is fine. They probably teach online statistics in other countries. Can we find that out? Okay, yeah, we can't. And the reason is the only way to know is to have a census, which would mean we would have to get in touch with every single online statistics student in the world and ask them and make them answer the question. And hopefully you know we can't do that. Do y'all agree? So what we do is we do the next best thing, and that is we use a survey. So we're going to take a sample of statistics students, and we are going to, instead of finding the population mean GPA, we're going to find the sample mean GPA. So, and we're going to use that as our best estimate for the population mean GPA, even though it won't be right. It'll be an estimate. Any questions on that idea? And we know it's the best estimate that we can get from a survey because if you remember, the population mean and the sample mean is an unbiased estimator of the population means. That was something we had in chapter 7. All right, so now what you have to do, and y'all have to do this, is you have to type in the chat box. And by the way, I believe that no one can see this on when it's published in YouTube, but it doesn't matter. Again, if you're not honest, I'm okay with that. We just need numbers. Okay. So I want you to put in the chat box your GPA, and I am going to put the numbers in. How about orange? And let's see what we got. 2.9, comma 2.63. Wow, it's pretty good. You actually know. That's with 2 decimal places. That's not bad. 4.0, not bad. 3.6. Get some more. 3.0, 3.5. 2.53. 3.8. And that's everyone list. Okay, so now the question is, a couple questions. One is, do you all know how to find the sample mean if you were asked to do that using a calculator? You all comfortable? That's not like a hard thing to do. So I'm hoping you can say yes, but if anyone needs help on that, I can explain how to do that. How do you find the sample mean of these numbers? And there's a few ways. Yeah, you could put it in the list, and then you can go to calculations, if you remember, var stats, and then choose L1, and that'll make it. You can also add them up and divide by, let's see, 2, 4, 6, 8. You could do that also. Okay, and in this case, so we could add them all up and divide by 8. And we can get that. So I'm not going to do that right now because we're going to do everything at once. And I want to get to that in a moment on the calculator. Okay, and in fact, I better write these down. I just realized if I don't, I lose it when I reshare my desktop. 2.9, 2.63, 4, 3.6, 3, 3.5, 2.5, 3.8. All right, so if we got the sample mean, then that's our best estimate for the population mean GPA. So now, one question for you is, how good an estimate is it? Okay, and what that means is, how much are we likely to be off by? Any questions on that idea? So how much are we likely to be off by? Any idea on how you might come up with how much are you likely to be off by, kind of on average? So what is the error in using the sample mean to estimate the population mean? And what things have we already learned about that will help us find that error? Any thoughts? Hoping you might answer. There's margin of an error. We haven't learned about that yet. We're going to be using that, but we don't even know what that is yet. It hasn't come up yet. Any thoughts? All right, if you're not typing it in, let me tell you the central limit theorem. Now we're going to have to make two major assumptions, which are probably wrong, but we're going to have to do it. One is we're going to have to assume that this is a representative sample of the population, that there's no bias involved. What do you guys think? Do you think there's no bias? Do you think you're representative of the whole population of the world? Definitely not. Definitely not. You're all in the same class. Okay? And it's a class in California, for example. So we're going to have to make that assumption. Remember what the first three letters of assumption are. So it's not a good idea to make that assumption, but we're going to have to do it. And there's another assumption we're going to have to make in order to use the central limit theorem. What's the other assumption we have to make? Okay, we can't, now random sample is the first assumption, Ross. And it doesn't even make any sense to assume we have over 30, because we don't, we have 8. So that's silly. So if you don't have over 30, what do you have to assume? See if you can remember. Yeah, we have to assume that the distribution of GPAs in the world for online statistics students is normal, or approximately normal is good enough. So let me write that down. So assumptions in this case. Okay, because certainly the sample size is not large enough. Okay, so one is the sample is unbiased. And two is that the distribution of the population is approximately normal.
Ever been here? Yes.
Okay, now if you have a sample size over 30, then number 2 you don't have to assume.
It automatically fills out.
For number 1, when you did project 1, you learn how to deal with that assumption. Is you can do a sampling technique that limits the bias. Does that make sense to everyone? And that's what you were supposed to try to do in project 1. There's always going to be some bias, but you could do whatever you can to limit it. And that could be with a really well done stratified sample or cluster sample. Okay, simple random is usually impossible, but you could do unbiased samples. I did not on this one because I just asked you guys. Any questions on that? Okay, but now that we have the assumption, I want to draw something, and hopefully you know what I'm about to draw because it's always the same thing. I'll make it black. So with those assumptions, the sampling distribution is approximately normal. Any questions on that? Now, the average of these numbers, I don't know exactly what it is now. I could put in a calculator, but I'll do that later, is somewhere else. Let's see, as soon as it's possible to have a normal distribution in the sample, but that is not true for the population. Absolutely. Well, I'm not sure exactly what it means for the sample to be a normal distribution, exactly, because we just have a sample size of 8. We just have 8 numbers. Does that make sense? So we just have 8 numbers, but if we had a large set of a sample that was unbiased, yeah, if we had a large sample that was unbiased, then, and you did a histogram and it looked normal, then it's likely but not absolute that the population was also approximately normal. Okay, if you have a small sample, you have no idea. Okay, so I want to give you a lesson in statistics. You should never have a sample size of 8. Okay, there's only one reason I'm doing this with sample size of 8. That's because there are only 8 of you. Okay, and I wanted to use y'all. Does that make sense? So usually you have large samples, and then you don't even have to worry about it. So if you have small samples, get a bigger sample. That's kind of the answer to your question. Because assuming you have a normal distribution is almost always wrong. Okay, it just usually isn't. Okay, so, but the point is that I'm assuming. So we do have this normal distribution. And what I want to do is I want to say, well, I want to be 95% confident of some interval of a GPA. So let me draw some more. So I want this area to be 0.95. Any questions on that so far? Okay, we could, if we wanted to, we could find the mean. We could find the sample standard deviation. Okay, and then use that with the central limit theorem and an inverse normal. Remember inv normal? To find out what these values are. Do you remember doing that last week? Okay, that's kind of what we were all about last week. There is one small problem with that. What's a small problem? Any thoughts? I'm not seeing it, but let me write it down. Sigma sub x bar, because that's what we need. We would need the sigma sub x bar is equal to, from the central limit theorem, sigma over root n. N is 8, not a problem. Do we know sigma? Absolutely we don't. In fact, we'll never know sigma. We'll never know sigma because if the way to get sigma is you use mu, and mu is what we're trying to find out. So if we can get sigma, we have mu, and we don't need to do any of this. Is that clear? All right, so because of that, what we have to do is we have to say, well, it's not really going to be normal because we're going to have to do an estimate of sigma. What is the best guess do you think you have for sigma based on our data? What's the best guess for the population standard deviation? Any thoughts? I'm not looking for a number, I'm looking for some words. Not seeing it. The mean of the sample is not likely to be anywhere near the standard deviation, but the sample standard deviation, the standard deviation of the sample, will be our best guess for the population standard deviation. Does that make more sense than using the mean of the sample to guess what the standard deviation is? Doesn't it make more sense to use the standard deviation sample to guess what the population standard deviation is? Okay. Yeah, so we're going to get the sample standard deviation. That we can get easily on a calculator. And that sample standard deviation is what we're going to use to estimate the population standard deviation. But it won't be perfect, and because it's not perfect, I'm going to put a little approximately equal to S over root n. Because it's not perfect, it turns out, and this is a weird story, we have to figure out how we're going to deal with the imperfection. And what we can think, believe it or not, is a brewer. That is someone who is into beer. Okay, I know that's, you were all thinking about that, right? There was a math professor who was working in a brewery and realizing that things weren't working because he was using sigma, and he came up with the mathematics to be able to deal with it. And he actually named it after his students, and he called it the student t-distribution. So we're going to use, instead of the normal distribution, we're going to use the t-distribution. And what that does is it takes into the effect of having to have an extra error because we're going to use the sample standard deviation instead of the population standard deviation. Any questions on that? Okay, if you happen to know the population standard deviation, then you can actually use the normal distribution. But we don't, so we're going to use the t-distribution. Any questions so far? Okay, the next thing we have to do, I want to mention is, why did I pick 95%? Any thoughts? Okay, yeah, it's within the standard deviation plus or minus 2, but it is a little artificial. I'll let you know that. Really, the true reason I picked 95% is because that's just because what everyone else uses. Okay, not everyone, but most people use a 95% to be happy enough that they're confident 95% of the time. And there'll be a 5% chance that they blew it. And that's kind of how social sciences pretty much always use 95%. Media almost always uses 95%. So remember that 95% chance, that means that there's a 95% chance that you're right when you do this calculation, and a 5% chance that you're wrong. Okay, now can you think of situations where that's not okay? Where you won't be satisfied by 95% chance of being right? And there are, that's a hint. Can anyone think of some? It's not a math question, this is a human question. Yeah, living, so let me give you, medicine. Okay, medicine. Pregnancy test, maybe. Pregnancy test might be good enough. Okay, because you'll find out eventually if you're pregnant. Okay, but what if you're 95% confident that this medicine is not going to kill you? So I'm going to go for the living thing. Well, would you be okay? Would you take that medicine? Okay, hopefully not. Let's say it maybe helped cure your acne a little bit. I hope you wouldn't be okay with a 5% chance of dying because you took some acne medicine. So there are some times where you want to go higher than 95% and do maybe 99% or 99.99% if you want to be really confident of being right. Okay, but take a look. If you want to be more confident of being right, let me show you what happens. If you want to be, say, 99% confident of being right, then you're going to be here and here. And the problem is your accuracy is not as good. So for example, we'll play around with this example actually. Okay, so now let's put it in a calculator. So if you have your calculator, follow along. I always recommend. It won't look exactly the same as mine probably because there's lots of different calculators out there. Sorry about that. But I'm going to share my calculator now. And the good news is the calculator does everything we need. So the first part you're used to. I'm going to go to, oops, not a second. I'm going to go to Stat, Edit. I'm going to clear L1. Hopefully you know how to do that. Never hit delete. And then I'm going to go to, I'm just going to type the numbers, 2.9. And then 2.63. And then 4, 3.6. And then 3, 3.5, 2.5, and 3.8. Okay, so that's something you should know how to do already. This is just putting data in. So now I'm going to have the data in. Now I'm going to go to Stat. And now this is the first time we've used this. And I want to let you know the rest of the course is all about this menu item. And that is tests. And if you look at the calculator, there's many, many, many of these. And as I mentioned, we're only halfway through the class. Pretty much our goal for the rest of this entire course is to go through just about all of these. So each week we're going to have a few more. And what we're going to be looking at now, so you're going to scroll down, and we're going to go to T interval. Remember I told you we're using the student's T distribution. So that's why we use T. Interval because we're doing confidence intervals. Then I hit enter. In this case, I have data. If it was to stats, I go to data because I have data. My list is not L3, it's L1, so I go to second one. Enter. Freak is 1, that's fine. Sea level, nothing to do with Tahoe being 6,200 and, you know, our college is probably 250 feet or so. Now sea level is the 0.95. Which it could be something else if you want more confidence or less confidence. And we'll play around with that. And I go to calculate. And there we have it. So remember I told you the calculator will get you everything we want. The mean was 3.24. Standard deviation, sample standard deviation was about 0.56. Sample size is 8. But now the important numbers here are, I'm going to round 2 decimals because that's what everyone does for GPAs. And when you're doing the assignments on the computer, you should round what they tell you to round. But when you're doing everything else, you should round to what's most reasonable. So we're looking at 2.77 to 3.71. Okay, so let's go and look at this and go back to Zoom. And let's type out our conclusion. Okay, any questions so far? I'm going to erase the assumptions and this other stuff because I don't think we need that anymore. Because we have a lot to write. By the way, this is the beginning of writing a lot in this course. For the rest of the course, we're going to be writing a lot. Oops, that's not what I wanted. That's what I want. Yeah. Okay, so here's what it looks like. If I ask you to interpret the confidence interval, and for confidence intervals, I'm always going to ask you to do this. Okay, you start out with the following words. With, in this case, it's 95% confident. The population mean GPA of online statistics students is between 2.77 and 3.71. Any questions about the interpretation of the confidence interval? Any questions on that? Okay, so if I ask you to interpret the confidence interval, you start out with the word with. Got it? So Charles, you should be able to see it, no? So I could read it to you again. Yeah, it should be up there on the screen. But it's interpret the confidence interval with 95% confidence. The population mean GPA of online statistics students is between 2.77 and 3.71. All right, let's interpret the confidence level. Okay, so to interpret the confidence level, that is what the 95% means. Okay, and that is kind of like a chance of being wrong. But the way you can say it, it's kind of long. There's no short way of doing it. What we can say, we can think of being in the business of collecting data and getting confidence intervals. And 95% of the time, we're going to be right, and 5% we're going to be wrong. And what does it mean to be right? It means that our interval, in this case, 2.77 to 3.71, contains a population mean, GPA. It might not, we don't know. But what we can say is that if we surveyed many groups of 8 online statistics students, then each group would result in its own confidence interval. Okay, so if I asked a different 8 people, I get different answers, right? I get a different confidence interval. Okay, I wouldn't get this 2.77 to 3.71. But what we could say is 95% of these confidence intervals would contain the true population mean GPA for online statistics students. Any questions on that? You asked where we got the 95%. As I mentioned that unless there's some reason why you wouldn't use a 95%, you use a 95%. So if someone is going to die because of your result, you might want to go to 99%. Honestly, I've done some consulting work, and whatever the client tells you is what you use, but you should understand what it means, just in case you need to advise a client. So for example, I did some work for the Forest Service where I helped them with their data. I help them analyze their data. And they wanted me to use a 90% confidence interval. And one thing that you should know as an employee or a consultant, the boss is always right. So they say use a 90%, I say sure. I let them know what that means. But if they're okay with being 90% confident about it, then they're okay with it. News always uses 95%. Okay? Or at least your standard news, like New York Times, CNN, Fox, all the main news stations will always use 95%. So the things like Gallup and Pew Research, they always use 95% also. Any questions on that? All right, I want to do something else because we can easily switch off. And let's explore what would happen if instead of a 95%, what if we used a 90%? Because you might look at this and say, well, yeah, I know that the population mean is something between 2.77 and 3.7, but that's like between a C and a high A. It doesn't say much. Do you agree? If I say, oh, the GPA is somewhere between a C and an A, I haven't learned very much. Do you agree? It's such a big spread. So if I want to decrease that spread, there's two ways of doing it. One way is I can change the confidence level. If you go to 90%, then I'll have a narrower spread. So let me show you what happens if I do that. So I'm going to go to the same thing I did before, but I'm going to change one little thing. I'm going to turn that 95% into a 0.9. And in a moment, now the spread is a little bit less. Okay, so now it's 2.9 to 3.6. Okay, and you say, well, that's a little better because now I know a little bit more. But what's the problem with knowing a little bit more? You have a narrower confidence interval, and it's like more kind of a better thing to say is that I know what the GPA is in a much narrower interval. But what's the problem? Yeah, I have a 10% chance of being wrong now. Do you see? So if I did this all the time, 10% of the time, I'd just be stating it wrong. Do you see? I'd be getting it wrong. So it's a give and take. So if you want a narrower confidence interval, you have to be okay with a smaller level of confidence. There is one way where we can keep the 95% and get a narrower confidence interval. And what's the way to do that? And there's a give and take in that too. Any guess? We talked about it last week, actually. Any thoughts? Yeah, larger sample size. Okay, but again, it's give and take. Get a larger sample size, then you'll have a narrower confidence interval, which is good, but it's a lot more work, right? How many of you guys would have liked it if I said on project one you had to ask 3,000 people? Would you have been happy about that project? Yeah, you would have probably dropped the class. Do you agree? Yeah, forget it. So the problem with the larger sample size, it's a whole lot more work. Okay, and if you're doing this in a business, for example, it costs more money to pay people to do that work. Any questions on that? So you can't have everything. Any questions so far? Okay, so that was an example. I want to do another example, and this is going to be a current event example. I like to bring those in too. So let me do a new share. Okay, so oops, at the top of this. All right, so this is Gallup. I like Gallup because they actually give enough information we can do everything. All right, less than half in the US would vote for a socialist for president. Okay, that's a big deal. Okay, why is that a big deal, by the way? This is not math, by the way. The reason why it's a big deal? Any thoughts? Okay, I guess you don't know your political science. Okay, we don't have a socialist. Okay. We have a type of socialist running. So it depends. It's kind of it's a general word, but we have a type of socialist running. Okay. Yeah, there's not a lot of socialist countries. The point is that if someone thinks they're socialists, then the person may not win. Do you see that? Which means that if somebody is running, they shouldn't say they're socialists. Because if they say they're socialists, they're not going to win. Do you see that? So we think about that. So now the question is, do we really believe it? Does Gallup know about half the people in the United States? Definitely not. Okay? I think you all know how they came up with their numbers. They came up with their numbers by doing a survey. So now I'm going to scroll down and we're going to look at some of the results. And here it is. 47% of Americans would vote for a socialist. Okay? So that's what they came up with. Now, again, they don't know that 47% of Americans would vote for a socialist. So what I'm going to do is I'm going to scroll down a lot. And that's survey methods. So now we're starting to read some of the survey methods that I ignored before because we can understand them. It said each sample of national adults, okay, included a minimum quota of 70% cell, 30% landline. Okay, that means there's a stratified sampling. Okay, with additional minimum quotas by the time read. Okay, but then here, and this is what we want. So first thing is they tried to prevent bias. That was one assumption we looked at. But here, for results based on the total sample of national adults, the margin of sampling error is plus or minus 4%, okay, with a 95% confidence level. So can you tell me what their confidence interval is if you believe what they said? So the hint is, again, 47%, that was their sample. That was their sample proportion, not their population proportion. So can you tell me what the confidence interval is, the 95% confidence interval? So from what number to what number? That's a hint based on what I've highlighted here. Any thoughts? The hint is you don't need a heavy calculator for this. You might use an arithmetic calculator, but you could probably do it in your head. I'm not hearing it. Okay, 95%, not quite. All right, let me do it. I need to go to annotate because I want to write right on it. That's fine. Oh, text. There we go. Okay. So what I can say is we have a plus or minus 4% margin of error. What that means is that's what they're off by in their confidence. The center of that is 47%. So if you take 47 and subtract 4%, what do you get? That's why I said you probably could do this in your head. 43. And I'll do it as a decimal. Now, if you take 47 and add 4%, because it could be off, up, or down, what do you get? 51, or 0.51. Okay, so this is important. That's what the margin of error tells you. It tells you how off from the sample proportion, or mean in the last example, are you likely to be, or from the population. And what we can say is that it should be somewhere between 43% and 51%. So when I look at this, I have some issues with their article. What was their article's title? Do you remember? And why do I have issues? And remember? I need to undo this. There we go. It says less than half of the US would vote for a socialist for president. Okay. So that says that it should be less than half. But it's not that unlikely that we're close to 51%, which is more than half. Okay, so it's one of those articles I look at, and I'm hoping you're going to get good at this too. It's one of the big points of taking this class, is to be able to read an article or read research and decide if the authors did it right. And I'm saying they didn't. Okay, and by the way, this isn't some old thing. This was posted on the 9th. So if their margin of error is correct, then they shouldn't have this title in the article. Do you agree? Because if it's somewhere between 43% and 51%, that could be more than half. It could be less than half. We don't know. You can't definitively say less than half with 95% confidence. Happens all the time that people blow it, you mean? It does. Okay, on the other hand, let's see if they blew it on the margin of error. Okay, or insert their own agenda. Let's see if they blew it on the margin of error. So let's take a look at that. And to do that, I'm going to go to my calculator. And you're used to that. Let me do the calculator. And I'm going to clear what I had. And now I'm going to go to stat and go right to tests. Okay, we're not in t-interval anymore because t-interval is for a population mean. And here we don't want a population mean, we're interested in population proportion. Do y'all agree? Because it's a yes or no question. Would you feel comfortable voting for a socialist is the question. So that means I'm going to go to what they call 1 prop z int. Okay? And by the way, we can do that without, we can do that because if you take 47% of their sample size, I don't know if you saw it, was 1,024. And if you take 53% of 1,024, you get bigger than 5. And with the yes-no question, you're talking about 5. With the mean quantitative question, you're talking about over 30. All right, so I'm going to go to the 1 prop z int. And I hit enter. And it asks for x. So x, remember, we had 47%. So 47% of 1,024, if you put that in a calculator, you get about 481. You should always use proper rules of rounding. Our n was 1,024. Which is a special number, by the way, for the computer science nerds like myself, because it is 1 megabyte is 1,024. You don't have to know that, though. That's just weird trivia. Confidence level. Let's go with 0.95 because that's what they said. They want to do a 95% confidence interval. And let's calculate. All right, so what we got is 0.43916 and 0.50029. Any questions on that? Which is actually not a 4% margin of error. It's a 3%. Because if you take 0.47, you add 0.03, you get 0.50. So Gallup blew it, actually, in like lots of ways. Okay. C level is a confidence level. Oh, did I get the wrong one? Let me do it again. I didn't check it, but let's double check. One prop z int. Yeah, I was right. 0.95. Yeah, C level is confidence level, and we're using 95% confidence. So C for confidence. Okay. So notice the margin of error is actually 3%, plus or minus 3%, not 4%. But it still might be a majority, but very slightly above. Do you see that? With 95% confidence. Because that's 0.50029, a little bit over 50%. Okay, it's more likely to not be a majority. But either way, Gallup didn't get it right. Any questions on this example? Okay, any questions? All right, here comes the next thing to talk about. Should we write a letter? I don't know what you mean, Russ. Oh, a letter to Gallup. If you want to, you can. To correct them, that's what you meant. I thought you meant what letter do you use to define confidence interval. You don't use letters for that. You just write the interval. So that's the kind of letter you meant. Okay, so let me do the next piece that I need to talk about. So I'm going to go back to, let's go to new share. There we are. And let's go to Paint. So I have a different question. Yeah, you should interpret it. I kind of showed you here. Again, I only have so much time. But you could say with 95% confidence between, it was, let me remind myself again, between 44% and 50% of all Americans. Notice the word all, that's necessary. I'll take off points if you don't say that. Between 44% and 50% of all Americans would not vote, or would vote for a socialist president, a socialist for president. Okay, so that's interpreting the confidence interval. And then interpreting the confidence level would be if Gallup did many studies, and by the way, Gallup does many surveys. That's their business. And each one had 1,024 people. Then each one of them would produce its own confidence interval for the population proportion of people who would vote for a socialist president. 95% of those confidence intervals would contain the population proportion of Americans who would vote for a socialist president. So very similar to the last example. And by the way, you'll get more examples when you're doing the homework because you'll have to do that. And I want to mention something. At this point in the class, it's really important that you keep a journal of the questions that you're doing and the answers. Because when I ask you about the interpretation of the confidence level, it's multiple choice. Because the computer, at least maybe I'm not a good enough programmer, to read your long sentences and have the computer grade the sentences based on your words. So it has to be multiple choice. But your midterm is not multiple choice. Midterm, you have to be able to write down the interpretations. So that's really important. So my strong recommendation is before you even look at the multiple choice, write down your interpretations on a piece of paper, and then look at the multiple choice, see which it matches, and keep that in your journal. Any questions on that strategy for success? And I make you do writing where I grade it once, and that is this week's discussion post. And I want to notice, I should say something. It's not good enough to just post an article. You need to respond with an analysis. There was a big group of you that did not respond with an analysis for last week's. And that wasn't a good thing, okay? It's not about losing the points, it's about not getting that practice. That's more important. If you don't get the practice, the midterm won't go well for you because the midterm makes you do it. So the discussion post assignments are actually the best practice for the midterm. So don't go lax in that. Okay, it's also where I can actually grade you and look at it and give you advice. All right, So now I'm going to reshare and go to Zoom. And we're going to talk about something a little different. I go to Zoom, go to Paint. And now we're going to talk about something different, but related. So I'm going to erase my interpretations because I need to do other stuff. Okay, so now I have a new question. Hopefully, remember I told you should never do a survey of 8 people. Do you agree? You should never do a sample of 8 because it's just way too many assumptions. They just don't work. All right, so instead, what we want to do is we want to say, well, how many do we need to do? Okay, and you might say 30, but that might not be enough. Okay, does that make sense? And why might that not be enough? What do you think? What might be the problem with doing, say, 31 people? Okay, it gets us over the issue of having to make that assumption, but what's the problem with it? Let me write something down while you're thinking. Too small, can include a large bias. Well, let's suppose that you can do a survey so that it's a nice, good old, stratified sampling with cluster sampling, just well done survey. There's a bigger reason. Any thoughts? Okay, the problem is if you look at the interval we ended up with 8, it was 2.7 to 2.8 to 3.7. It doesn't give you any information. Do you agree? You kind of knew that before you even looked at the data, that it ought to be somewhere in between a C and an A in terms of average GPA. Do you agree? And we want to know what the GPA is. We want to be off by maybe only 0.1. So I have a new question. The question is, how many students must be surveyed so that the margin of error is no more than 0.1. And just for fun, because I want to make, we'll look at this in a bit. And we're going to use with 95% confidence. So a couple things. One is the 95% confidence, when I give it on a test, it'll be another number because I want to make sure you do what I'm about to do. So pay attention. Don't memorize a number with 95%. All right, so the first thing we need is a formula. And this one I have to give you. So, by the way, very strong recommendation. Put this formula on your note card for the midterm and the final, because you probably don't want to memorize it. You know what? I want to do pen because it has messy stuff. And that is, oops, that was my mistake. One more time. N. So first thing, how many students must be surveyed? That's a sample size question. Do you agree? And N is a sample size. Is equal to Z times sigma over E squared. don't have enough time to prove this to you, but do you all believe me? So this is a formula. So now we got to figure out what all these numbers are. So let's do the easy ones first. E, what is E in this case? Sample number, no, it's, N is a sample number. Yeah, what is E? E. Yeah, E is the error, and in this case, it's 0.1. I want to start with the easy ones. E for easy. Okay, sigma, we don't know, but our best estimate for sigma, in this case, is 0.56. And the reason for that, and if you didn't write it down, our calculator gave us that. So when we did this, when we did these numbers, it gave us a standard deviation. Do you remember that? So sometimes we'll call that a preliminary estimate for sigma. And it's as good as we can get. Okay, Z takes some work. So I'm going to draw a picture. And as soon as I say that, you should know what I'm about to do. There's our picture. And we want a 95% confidence interval. So that's 0.95. And Z is that value there with a standard normal curve. You've learned that before, right? We use Z when we're talking about standard. So that means the mean is 0, the standard deviation is 1. Any questions on that? Okay, so if this middle area is 0.95, how do we get this left area? Can you tell me what that is? I think you got the right idea, Ross, but you missed a decimal. It's 0.05 over 2, yeah, or 0.025. Because if 95% is in the middle, 5% is on the outside, half of that is 0.025. So if we know the area to the left, in our calculator, what do we do to find the value of Z? Yeah, we use inf norm. So let's write that out now. So you starting to see why we had to do all those other chapters so that we can understand this stuff and make it work. So Z, in this case, is equal to the inf norm of 0.025. The older calculators, that's enough. With the newer calculators, you have to put comma 0, comma 1. Okay, or 0 for the mean, 1 for standard deviation. And when you do that, I'm going to assume you all know how to do that because I only have so much time left. You get about negative 1.96. Any questions on that? Okay, and what we used with the empirical rule is we said -2, but now we can be more accurate because we know inf norm is the way you actually get that. Any questions so far on what we're doing? Hopefully you're seeing how we're bringing everything together now. Okay. This square, by the way, if you take a square root of both sides, you'll see a root n. That was the denominator with the central limit theorem. It all comes from old stuff. Okay, now you just plug it into our calculator. So actually, I want to go brush. So we can say that's equal. Because I'm squaring it, I don't need the negative, because negative squared is positive. 1.95. Oh, it should be 1.96. Sorry about that. How did I write that? That's better. Okay, and you can get that in your calculator. So you get 1.96. There we go. 1.96 times sigma is 0.56. Didn't write sigma there. Divided by 0.1. And we square that number. Tell me what you get when you put that in your calculator. Let me do it in my head. Yep, I get that too. And I got it. I could do it. I couldn't get it to 4 decimal places, but in my head, I could do it to a whole number. So about 100. So notice, by the way, we should always round up. By the way, so what you get is 120.4726. But you can't survey 120.4726 students. Do you agree with that? Doesn't make any sense. Are you going to like take a chainsaw to one of them and only ask that part of them? No. So instead what you do is you round up and you do 121. So let me write that out. And that's the sample size. Notice it's much bigger than 30. Okay, it's much, much bigger than 30. 30 is just to make sure that you have a normal distribution for the sampling distribution. But the 121 is so that you have a confidence interval that has a satisfactory range. Do you see the difference? They're very different. So if there's 95% inside, let's write this out. You do 1 minus 0.95, and that's 0.05. And then you take 0.05. 0.05 is outside, but we only want the left, so we get to divide by 2. 0.025. So it's basic geometry, actually. Does that make sense, Bailey? Okay, I don't have time to do like big full examples, but I want to let you know that I could ask the same question with proportions. So if it was a yes or no question, we're going to have a different formula. First thing, there is no sigma for a yes-no question, right? There is no standard deviation when you have a yes-no question. So it's not going to be the same formula. There's going to be 2 formulas. So I'm going to erase all of this stuff, except for this one formula, or at least some of this stuff. So if you want to find out, for example, what % of all Americans would vote for socialist, and you didn't know anything, right? You're coming out cold, you had no idea, then it's a different formula. So that's going to be n is equal to 0.25 or 0.25 times z over e squared. Okay, so if you have no idea about what the proportion is going to be, then that's the formula you use. Z we know how to do. You draw a normal curve and You subtract from 1, divide by 2, you do inverse norm, and that gets your z. E be given. And 0.25 is just there. Trust me, it's always there. On the other hand, let's suppose we wanted to do another study. And remember, we had 47% in this first study. And maybe we're going to do a study next month to see if it's any different. So if we have a preliminary estimate, we have a different formula. And that's n is equal to p times 1 minus p times z over e squared, where p is your estimate, where you have an idea of what that proportion might be. Notice if your estimate was 50% or 0.5, you end up getting the 0.25. 0.5 times 0.5 is 0.25. 5 times 5 is 25. Okay, so this is for proportions. You have two different choices. I don't have enough time to get into it, but what I do have enough time is to do the secret word, because we need to do that. And you will have, the long video shows you how to do these, by the way. The book shows you how to do these too. I can't do every detail of the whole class in the webinars, but I try and take highlights, and I want you to know you do need to have those three formulas. Strongly recommend you put those on your formula sheets. Okay, so now we have our secret word. Make it a little bigger. And the secret word is estimate, because a confidence interval provides an estimate and a range for the population mean or the population proportion. Any questions on this idea? I just want to let you know, because I do have a little bit of time, I want to talk about something that's really important, and that is your project, project 2. So we don't need all this again, so I'm going to unshare. All right, so project 2. One of the main things you're going to have to do, any guess? Given that I'm saying it now? Should be obvious, that's a hint. No guesses? Yeah, find a confidence interval. Okay, you're going to have to find a confidence interval. So you're going to conduct another study, okay, and you're going to find a confidence interval, and that's going to be one of the main things. Next week, we'll talk about the other main thing, and that is do a hypothesis test, but that I'm not ready to talk about yet. But you're going to find a confidence interval. It turns out, though, the confidence interval is going to be more complex than what I did today, because it actually covers what we're doing in 2 weeks, and that is confidence interval where you're making a comparison. So you're going to make a comparison between two things. So for example, you might want to find out maybe, I don't know, how much taller the average man is than the average woman. And you might survey men and women to find out how tall they are. Then you're comparing men and women. Do you see that, how that works? Very different than project 1 when you weren't allowed to do a comparison study. For project 2, you must do a comparison study. What we haven't learned yet is in your calculator what to do a confidence interval when you have a comparison study. But actually, we're not going to use a calculator. You're going to use a spreadsheet, which is much easier than the calculator, it turns out. You just type in your data and you're done. So we're going to be doing a comparison study, and you're going to find a confidence interval. And just like I showed you on the calculator, but even easier on the computer, you can play around with different confidence levels, like 90%, 95%, 99%. And you can look at them and say which is the one that works for you. Okay, it seems weird, but you can do that, and that's fine. And I'm going to want you to do that. So just some thoughts. You should, one is have partners or get partners quickly if you don't. And next is start thinking about something you might want to compare that would be interested to a client, where you're comparing one mean to another mean. And one more thing is that it does not have to be a survey. Okay, so for example, let me give you an example one, and this would only work probably if you're in Tahoe, is this weekend, this Saturday. I don't know if you know, what was the big thing in Saturday in Tahoe? Do we have any Tahoe people here? It was an event in Tahoe. All right, maybe we don't have any Tahoe people, I'm not sure. But it was Clean Tahoe Day. So I actually volunteered, I went and cleaned trash. Okay, and I got the best piece of trash, by the way, of anyone in all of the Clean Tahoe Day. Anyone know what that best piece of trash was? And you will all agree with me, no doubt I found the best piece of trash. It was a piece of paper in the dirt. Yeah, $20 bill actually. Okay, but that's not what the conference interval might be about. But you might want to look at, say, last year's Clean Tahoe Day, okay, versus this year's, to see if there's more trash last year versus this year. And they would have data on how much trash the average person picked up. Does that make sense? So it doesn't have to be a survey, it could be collected data already. But it can't be something that's already found a confidence interval. It has to be something you're doing the confidence interval of. Does that make sense? So an article that has a margin of error is not okay, because they already did it for you. It has to be one where they haven't done it yet. And Clean Tahoe Day has not done that. Does that make sense? Or you might say, you know, is there more trash in the Sierra Tract area of our neighborhood versus the Tahoe Keys area of our neighborhood? Okay, and that data is available. Does that make sense? And those are the kind of things that people can do. Okay, you're doing a comparison study with data, and you're going to do a confidence interval. Can you do festival tickets sold last year versus this year? Only if it's a sample. So do you have a sample, Brenda? If you know how many tickets sold, and then that's really not a sample, because that's just two numbers. Do you see? Number of tickets is just a number. It's not a sample. Whereas if I look at each person's amount of trash they picked up in the many people that were involved, then you compare them. Do you see that? But if you somehow could collect data on this, but you may not be able to, if you can collect data on how much money individuals spent at the festival last year versus this year, and you had receipts of, say, you know, 35 last year and say 40 this year, then that is two samples. And then you can compare whether last year was more lucrative than this year or vice versa. Does that make sense, Brenda? So that's the way you can do something with festival, but you have to be able to find that data. If you don't have the data or can't get the data, then it won't work. Okay, so it doesn't have to be you asking a survey, it could be you collecting data. The other thing is that the data you're collecting, the sample size has to be much smaller than the population size. And if you can get a census, then that won't work for the project, because there's no reason to do a confidence interval if you can find out the population mean. So an example that doesn't work, for example, would be if you wanted to find out who scores more runs in baseball last year, the American League or the National League. And the problem with that is that's easy to find the data of all 162 games. Do you see that? But if you had a giant sample that you couldn't get, that's different. But if you had, or not last year versus year, who scores American, maybe Dodgers versus Yankees might be better. Because you can easily get the 102 games of the Dodgers, 162 games of the Dodgers, 162 games of the Yankees, and you have a census and you get mu. You don't have X bar trying to get mu, which you can never get. So it has to be a mu that you can't get. Have I lost you, or is that clear? Okay, that's pretty much what I have to say. Next week, we'll talk more about the project, by the way. We'll talk about the hypothesis part of the project. But if you have any questions, this is a great time. We're not at 7:30. I always try and make it before 7:30 to finish. And next week could be Monday or Tuesday. I don't really care. Either work, I believe. The following week is going to be Tuesday because Monday's a holiday. And I don't do webinars on holidays. Okay, we could do it Tuesday in the daytime. The following week, though, is the exam week. So that could be a little later. We could even do it Wednesday because I want you to focus on the exam. So I often have it later. So when the following week can be a Tuesday or Wednesday, but not Monday. Okay. And then let me double check. Yeah, so next week it could be probably gonna be Monday. I'm looking at next week. So I realize I have a meeting in the evening on Tuesday. Is the exam on the 29th? Yes, it's the 29th or earlier. So you could take it the 28th. If you're thinking about taking the 27th, then the problem with that is you probably won't find a proctor because that's, I believe, Memorial Day. The 20th, the problem with the 20th, I've written the exam, I'm ready, but you won't have learned the material by the 20th. So I strongly recommend no earlier than, say, the 24th, because you won't have done enough of the work. A lot of the exam covers chapter 9. And if you were to take it on the 20th or the 22nd, then you won't have learned chapter 9 yet. Do you see that? Okay, it's not against my rules to take it that early, but I strongly recommend you take it later because it's too much to learn. Okay. Oh, 20th for the webinar. Okay. Yeah, the 20th for the webinar is probably when it's going to be because the 21st doesn't work for me. I don't know if I mentioned this, but I don't know if you've heard of the Boys and Girls Club of America. I'm on our local board for that, and we have a board meeting on the 21st. And I promise that. I believe in helping children, so that's my way of giving back to the community, or one of my ways. And cleaning up trash, I did that too. Okay, so yeah, for the webinar, it's not a problem. But the test, the 20th for the webinar, that's fine. Yeah, the 22nd for the exam. The problem is that you need to get way ahead if you can do that. I'm not against it, but be ready to like work your butt off for the next 7 days. Like if you don't have a whole lot of time every day, it's not going to work for you. And you're not going to get my webinar because you'll be taking the test before, basically probably 2 days after the webinar. You won't have much time to study. After the webinar on the 20th, let's see. Webinar on the 20th, I'll be giving an exam review. So next week's a really important week. Okay, and then I'll do more review on the 27th. No, just 20th is when I do the review, sorry. 20th is gonna be a busy day. Yeah, the 23rd is better than the 22nd, obviously. Each day after is better. Okay. And again, you don't have to take it in Tahoe. If you can find a proctor in your area, that's fine too. You don't have to drive up to Tahoe.
Is the test going to cover a lot of chapter 6, 7, 8, and 9, or is it going to be a cumulative of everything? Sorry, I don't know where my little chat box
It's
is.
going to be mostly 6, 7, 8, and 9, but there's going to be a little bit on earlier stuff. That make sense? So I think it's like 10 problems, and there'll be like maybe 1.5 problems on chapters 1 through 5, and the others will be 6, 7, 8, and 9.
Thank you.
Yeah, it might be 2 problems, but so most of it is going to be the 6 through 9. And that's why taking the test really early is going to be a problem, because chapter 9 is covered in a big way. 6, 7, 8, and 9. Yeah, you definitely need to know normal distribution, which is chapter 6. Okay, any other questions? These are good questions. Again, the whole point of the webinar, a big point, is to be able to do the Q&A, immediate response stuff. Okay, thank you, Constance. Any other questions? Thank you, Zach. Any other questions? Brenda or Bailey or Esther or Jacqueline? As always, I'll stay until there's no questions. Okay, thank you, Bailey.
I have no idea how to exit this thing.
Oh, there's a leave meeting button. You might have to go to more and then leave meeting. That's possible. Otherwise, I'll just say goodbye to everybody.
Yeah, thank you.
Okay, I think I'll say goodbye. I don't see Brenda saying goodbye. He's the only one that hasn't said goodbye. But I think I'll say goodbye because I'm not seeing anything. Brenda, okay, thank you, Brenda. And for all of you who are watching this as an archived lecture, don't forget the secret word. It's in there somewhere. And don't forget that you should be making sure you got your partners for the project, and post on the Q&A form if you have any questions about anything other than the project too, and then you post on the project 2 form. I separate those because there's so many questions otherwise. But have a great week. And again, next week will most likely be Monday evening. I do have Tuesday lunchtime. That's the only other time that I really have available. So take care, and I'm going to end the meeting for everybody.